Alright, today you're going to be learning about angle relationships. This will be the last lesson for our geometry work, and we'll review some angle things that you have learned before, but some new concepts with angles and how they're related. So today, as you go through this lesson, you need to be able to identify the types of angles that are formed by parallel lines that are cut by a transversal. And then you also need to be able to calculate the measure of a missing angle when two parallel lines are cut by a transversal. So, if you take a look at this visual here, notice that there are 8 angles and only one of them is given to you. By the end of class, you will understand what kind of relationship these angles share, and you will be able to identify the measure of each of these angles. So only given one by the end of class, you need to be able to say what the angle measure of all of those are. Alright, so if we take a look at our vocabulary here, these are the different angle relationships and new angle words that we need to make sure that we understand. So you have a note sheet, and it starts on this slide with these vocabulary words. So we're going to talk about what parallel lines are, perpendicular lines, what a transversal is, how vertical angles are related, what supplementary angles are, what complementary angles are, what a linear pair of angles is, what corresponding angles are, what alternate interior angles are, what alternate exterior angles are, and what same side interior angles are. So those are the different ones we'll be going through. You have a note sheet that has the definitions and some examples, so please make sure you follow along as you go through this video. Alright, parallel lines. So you should have talked about those before, but parallel lines are lines that do not intersect. Parallel lines are always the same distance apart from each other. So I'm sure we've talked about in class before that, remember, parallel lines have the exact same slope. They're going in the same direction at the same rate. That's why they will never touch each other. So in the illustration here, you can see line L and line M are both horizontal lines. They will never touch. They are parallel. And then over here on the right hand side of your screen, you would say line AB and line CD are parallel. You see down in the notation that the parallel notation are two vertical lines, basically representing that something is parallel. Okay, perpendicular lines. These are lines that intersect to form a right angle. So if you take a look at this picture here, lines M and N meet at that 90-degree angle. The notation is, a little vertical and horizontal line that meet, because that's showing that they meet at a 90-degree angle. So M is perpendicular to N, and again, there are 4 right angles that are formed. This is like the coordinate plane. We talk about that quite often. Okay, a transversal. So here's a newer vocabulary word. A transversal is a line that intersects two lines at different points. So if you take a look at this illustration here, I have 2 parallel lines, and line T goes in the opposite direction. It doesn't have to be at a 90-degree angle, but it does go in a direction, the opposite direction of the parallel lines, and it does intersect them. It goes through those 2 lines. Notice that this looks very similar to the beginning problem. I told you that by the end of the lesson you need to be able to solve. It does form 8 different angles that we're going to learn the relationships of. Alright, vertical angles. So here's that illustration again, labeling, line T is the transversal going through 2 parallel lines, and it does form 8 angles there. So vertical angles in this figure are 2 angles that are opposite angles. They're opposite from each other. They are always congruent. So if you look at the illustration again, you see angle 1 and angle 4. They are opposite angles. they are congruent. Okay, angle 2 and 3 are opposite angles, so they're vertical angles, and they are congruent. Angle 5 and 8 are vertical angles, they are congruent, and angle 6 and 7 are vertical angles, and they are congruent. So if we take a look here at this diagram, to find the measures of the missing angle, if I look at this angle here that is 125 degrees, well, the one that is vertical from it is across from it, so that would be right here. And if we remember, vertical angles are always congruent, so this angle would be 125 degrees. Okay, if I go down here to the 55-degree angle, the question mark is opposite of that, so it is showing the vertical angle relationship. And because vertical angles are congruent, that means that this is 55 degrees. Okay, so again, I would be able to say that the angles directly across from them are congruent. All right, a few angle relationships that you should have covered earlier in your learning are complementary and supplementary angles. So remember that complementary angles are two angles whose sum is 90 degrees. So this is shown up at the top on the right. 40 plus 50 does equal 90. They do not have to be right next to each other though. So like this angle 27 and 63, they do add up to 90 degrees, so they are also complementary. In the diagrams below, in the right-hand corner, you see that supplementary angles are angles whose sum is 180 degrees, or a whole line. So we have 140 degrees plus 40 degrees gives me 180. You see that does form a line. They are adjacent. They're right next to each other. But they do not have to be adjacent. Angles do not have to be adjacent to be complementary, supplementary. So the bottom diagram here, 60 degrees plus 120 degrees, those are supplementary, but they do not have to lie next to each other. But again, if you hear the word adjacent angles, those are two angles that share a common side. They are touching right next to each other. So that would be the first diagram and the third diagram here, whereas the second and the fourth are just showing two angles. All right, so if we take a look at our supplementary angle relationship, if we go back to our two parallel lines cut by a transversal, you could also call those angles a linear pair, which a linear pair are two angles that form a line, 180 degrees. So supplementary angles and a linear pair are the same thing if the supplementary angles are adjacent. So if I take a look at this diagram here, angles 1 and 2 combine together to make 180 degrees, that straight line there. Angles 2 and 4 make that straight line of T. 3 and 4 make the same straight line of 1 and 2, so that's also 180 degrees. And 1 and 3 make the same transversal line T as 2 and 4, so that is also 180 degrees. So you could do that down here on the bottom as well. 5 and 6 are supplementary and also a linear pair. 6 and 8 are supplementary and also a linear pair. 8 and 7 are also a linear pair and supplementary. And 5 and 7 are also a linear pair and supplementary. So all of those combinations of angles add up to 180 degrees. So they are called supplementary or a linear pair. All right, so if I take a look here at this diagram, I have the upper right-hand angle is 72 degrees. I want to find out the two missing angles here. So if I remember, the ones that are missing actually show that they form a linear pair with 72, which is 180 degrees. So I'm going to take 180 degrees minus 72, and when I do that, I will get both of those angles. Like, they'll be the same degree. And if you remember, that is also because the two that I am finding are vertical angles, and if they are vertical angles, they are congruent. So if I do 180 minus 72, I get 108. So the angle to the left and the angle to the right are both 108 degrees. All right, moving on to corresponding angles here. Okay, corresponding angles are two angles that occupy corresponding positions. So they are in the same position. Okay, so for example, top left of each of those red lines, those are corresponding angles. Top right of those red lines on the opposite side of the transversal are corresponding angles. Whereas bottom left would also be corresponding and bottom right would be corresponding. So you could say here that 1 and 5 are corresponding, 2 and 6 are corresponding, 3 and 7 are corresponding, and 4 and 8 are corresponding. Alright, so if we want to find the missing measure when I'm talking about corresponding angles, I notice that the question mark is in the same position as 145 degrees that is above. So that means that the angle that is missing is 145 degrees. So those are corresponding angles. Alright, alternate interior angles. Okay, gets a little bit more complicated here. Notice I have the same image, two parallel lines, the red lines there. They are cut by transversal line T. It does form angles 1, 2, 3, 4, and 5, 6, 7, and 8. We've already talked about vertical angles. We've already talked about supplementary angles or a linear pair. And we've talked about corresponding. Now if you want to think about this, alternate interior angles. Okay. Well, if I think about the word alternate, alternate means changing, okay? So like if you go to a musical or a play or something, you might see in the program that the alternate was performing for the evening, and that means like the fill-in or so they changed who was filling in for the lead role, okay? And if I think about the word interior, interior means inside. So I know that I'm going to be talking about this yellow shaded area. I'm going to look at the inside of the two parallel lines. And if I think about, again, what alternate means, opposite or changing, not the same. So if I look at this diagram, I don't have to talk about angles 1 and 2 and 7 and 8. We're talking about 3, 4, 5, and 6. So if I look at this, alternate interior angles 3 and 6 is one of those pairs, and 4 and 5 are another pair. Okay, so 3 and 6 are alternate interior angles, and 4 and 5 are alternate interior angles. And alternate interior angles are congruent. So if I gave you angle 3, you would tell me that angle 6 is exactly the same. If I gave you angle 4, you would tell me that angle 5 is exactly the same. Okay, so take a look here at this diagram. Again, we still have our two parallel lines that are cut by a transversal. And they give me, on the left-hand side, on the interior of those parallel lines, they give me the 82 degrees and 98 degrees. They want me to determine the angle measure of the bottom right-hand interior angle. So if I remember, alternate interior angles, 82 is the alternate interior angle from this one that is missing. So the missing degree is 82 degrees. All right, let's go ahead and move on to alternate exterior angles. So these are very similar to what we talked about on the slide before, but these are two angles that lie outside the parallel lines on the opposite sides of the transversal. So again, we are looking at alternate, so opposite sides of line T, but now we're looking at the exterior, which exterior means outside. So we can get rid of angles 3, 4, 5, and 6. Now we're just looking at angle 1 and angle 2 and angle 7 and 8. And again, if I think about alternate, opposite sides of that transversal, so angles 1 and 8 are alternate exterior, and 2 and 7 are another pair of alternate exterior. And once again, those angles are congruent. So angle 1 is congruent to angle 8, angle 2 is congruent to angle 7. Alright, so if I give you an example here, take a look at these two parallel lines cut by that transversal T. I'm now giving you 120 degrees on the upper left and 60 degrees on the bottom left. And we want to find this missing angle on the bottom right. I notice that it is on the opposite side as the other two, so that means that I have to go with the 120 degrees. Now, some of you may ask, well, why can't I go with the 60 degrees? Okay, you're right, it's alternate and they are on the outside. However, remember that 60 degrees has to add up to 180 with whatever I'm finding. So if I were to put 60 there in my answer, 60 plus 60 is only 120 degrees, and I have to make a straight line 180 degrees. So that's why we go with the opposite side diagonally from where we're looking for. So that missing angle is 120 degrees. All right, consecutive interior angles or same side angles. This is the last one that we will look at before we want to be actually finding our measures in a whole diagram. So these are two angles that lie between the parallel lines. So again, the word interior is there, between the parallel lines. And consecutive meaning they are on the same side of that transversal. So let's get rid of angles 1, 2, 7, and 8. And if I look at angles 3, 4, 5, 6, same side angles are angles 3 and 5 and 4 and 6. So angle 3 and 5 are consecutive interior or same side interior. And angles 4 and 6 are also consecutive interior angles. They are also a linear pair, like we talked about earlier. So that means that angles 3 and 5 add up to 180 degrees and 4 and 6 add up to 180 degrees. This is not like many of the other relationships that we showed that are congruent. So these two make that linear pair or are supplementary, so that is 180 degrees when you add them together. Alright, so if I take a look here at this diagram, if I want to find the missing angle, I know that these are same side or consecutive interior. They're on the same side on the inside. They have to form that 180 degrees. So I would take 180 minus 135, and if I find that, I get 45 degrees. Alright, so if we go back to the beginning of our PowerPoint or video here, I showed you this diagram and said that by the end of class you need to be able to find all of the missing angles. Okay? Again, I want you to notice that there are two parallel lines, L and M. Even though they're going in a different direction than many of the examples I showed, they are parallel and they are cut by a transversal. So they form angles 1, 2, 3, 4, 5, 6, 7, 8. I want you to notice that angle 8 is the only degree that is given. So that, and it shows that it's 135 degrees. So this is where I want to be using my knowledge of all of those types of angle relationships that we just covered. So if you need to go back to in your notes and kind of look as I go through this and explain this, that might be helpful to you to see those diagrams and see those definitions. But the first thing I want to think about is, how am I going to get anything around 135? I want to start with the 5, 6, and 7, because if I get those, I can easily get the 1, 2, 3, and 4. Okay? So the first thing in my mind, I see that 135 is directly across from angle 7. And if I remember, those are vertical angles, and vertical angles are congruent. So that means that on here I can write that this is 135 degrees. Those vertical angles are congruent. Okay? Now, those vertical angles are congruent, so, and they form a linear pair with angle 5 and angle 6. Well, I know that 5 and 6 are congruent because they're also a pair of vertical angles. But now what I have to do to get 5 and 6 is I need to take 180 minus 135. If I do that, I'm finding this linear pair here or this linear pair here. So again, 5 and 6 are going to be the same, they're vertical, and they both form a linear pair with 135. So if I go ahead and do my math here, I am left with 45 degrees. So angle 6 is 45 degrees and angle 5 is 45 degrees. Okay? So I have found angle 5, 6, and 7. Now I want to look at 1, 2, 3, and 4. Okay? Now there are many ways that you can think about this. I could go with corresponding, so they're in the same location over on line M. I could go with linear pair with angle 5 and 1. They make a linear pair. So knowing that over here the linear pairs match up with the linear pairs over there. I could go with alternate interior. I could go with alternate exterior. There are many ways that I could think about this. I find the easiest way is to be using those ones that are congruent. So if I think about corresponding angles are congruent, vertical angles are congruent, but I don't know any of the 1, 2, 3, or 4 yet, so I can't use vertical angles. Alternate interior are congruent and alternate exterior are congruent. So I'm going to go ahead and with the 1 and the 4, I'm going to use the alternate interior. So angle 7 is an alternate interior angle to angle 1, and they are congruent, so that means that angle 1 is 135 degrees. Again, same side could also be looked at here, same side interior, that adds up to 180. There's a calculation involved rather than just knowing they are congruent, but angle 1 and 5 do add up to 180 degrees as well. All right, going on to angle 4 here. Angle 5 and angle 4 are alternate interior. They are congruent, so I know that angle 4 is 45 degrees. Okay? Now, if I take a look at what's left, I have angle 2 and angle 3. I know that they are vertical angles with the other two that I just found. Angle 3 is a vertical angle of angle 1, so I know that that's 135 degrees. And angle 2 is a vertical angle with angle 4, so I know that that is 45 degrees. So again, I used those relationships. I did one calculation, and from that one calculation, I was able to get all of the other angles. I want you to notice that the 4 angles on the left are exactly the 4 angles on the right. They are in the same location. So 8 and 1 are the same, 5 and 2 are the same, 6 and 4 were the same, and 7 and 3 were the same. So even though I took a little while explaining this and going through this work, this should be something that you clearly can do very quickly when you get to your practice activity. All right, let's take a look here at a different problem here. Oops, let me go back here to that. Okay, so if you take a look here at this, notice that I have a lot more angles on this diagram, but I see that I have all of those same relationships that we just talked about. Okay, so if I were to tell you that angle 11 is 65 degrees, okay, you should be able to find all of the other angles. Sorry, on your note sheet it says 62. So let's make that 62 degrees. So if on your note sheet, you can write that in, please. Okay, it is, so angle 11 is 62 degrees. So if it is 62 degrees, from that one angle, I should be able to find all of those other angles, which would be 15 other angles. Again, I like to start with vertical angles first, so that means that angle 16 is 62. Okay? So now I know that angles 11 and 12 form a linear pair, and 15 and 16 form a linear pair. So to get those, I'm going to take 180 minus 62. So if I do that, I get 118. So angle 12 is 118, and angle 15 is 118. Okay? Forgot my degree symbols here. Okay, so now if I go ahead, it doesn't matter if I go to 9, 10, 13, 14, or if I go to 3, 4, 7, or 8. But again, corresponding angles, alternate interior, alternate exterior, whatever you want, those are all congruent. This time I'm going to go with corresponding. So remember, corresponding angles are the angles that are in the same position but up on a different line. So like angle 11 here that we knew was 62. That is in the same position as angle 3. So I know that angle 3 is 62 degrees. If angle 3 is 62 degrees, then angle 8 is 62 degrees. It's corresponding with angle 16, but it is also vertical from angle 3. Okay? If I go back to my corresponding definition, angle 15 is corresponding to angle 7. So I know that angle 7 is 118 degrees. And then angle 7 is vertical from angle 4, so that means angle 4 is also 118 degrees. Okay, so now it doesn't matter if I go to 1, 2, 5, and 6, or 9, 10, 13, 14, but again, I'm going to use the same idea. Angle 3 is corresponding to angle 1, and so they are equal. So this is 62 degrees. Angle 4 is corresponding to angle 2, so that's 118 degrees. Angle 6 is corresponding to angle 8, so that's 62 degrees. Angle 7 is corresponding to angle 5, so that's 118 degrees. So if I take a look at that, I mean, these are all, every group of 4 are exactly the same if you notice. So I can go ahead and just write that in here and know that I am finished. So I just, knowing one angle, I used those relationships and found all of the others. All right, and the last one here, this is kind of just taking it up an extra level. You'll notice that there's an algebraic phrase here on angle 4, so it's 5x plus 35. There's a little bit more math involved. Here you wouldn't want to find all the missing angles. You would actually want to find out what x is. That's what they would be asking. So feel free, if you don't feel like you're ready for this, to skip this slide. But please make sure that once you're done, you go show the substitute your completed note sheet. And once that you show them your completed note sheet, then they will give you the practice sheet. Okay? And then you can work on that practice sheet for the rest of the time. And if you get done with it, put it in the tray, please. If you don't, then it needs to be completed for homework and brought back. We will, as a class, review what these angle relationships are tomorrow and talk about them just so that I can clear up some confusion if needed. Okay, so let's go ahead and take a look at this if you're willing to. So notice that I do have to use some relationships to understand how I'm going to find x here. So I noticed that 5x plus 35 and angle 3 are a linear pair. They add up to 180. So if I could find out what angle 3 is, I could put those added together equal to 180, and I could actually solve for x. Well, I noticed that angle 3 is corresponding to the 45-degree angle that is labeled here. So this is 45 degrees. So I know that 5x plus 35 plus 45 equals 180. So this is just an equation that we have to solve now, and once I have x, I could actually find out that entire angle measure. So I would have 5x plus 80 equals 180. So I subtract 80, I get 5x equals 100. I divide by 5, and I get x equal to 20. So x is 20 degrees. So then this angle measure would be 5 times 20 plus 35. So if I find that, that is 100 plus 35. So this angle measure over here is 135 degrees. So now based on that, I can find all of the others. 1 is 135 degrees, 2 is 45, 6 is 45, 5 is 135, and 8 is also 135. So using vertical, alternate interior, alternate exterior, corresponding, same side interior, all of those thoughts, linear pair, we can find all of those missing angles. Alright, so make sure you go show your note sheet to the substitute, please. Get that practice sheet. And on that practice sheet, you should be able to identify the types of angles that are formed, and then also calculate the missing angles when you have two parallel lines cut by a transversal.